Okay, on page 706, and the questions from chapter 25, I asked you to do numbers 1 to 4. Number 1 says, a north-south wire is moving towards the east through a magnetic field that is pointing down. So if we call into the page north and out of the page south, then this would be west, this would be east, and my wire then is running like back here, okay? And my magnetic field, it says, is pointing down. That's why I couldn't make my north up here, okay? So this is my magnetic field. And it says, what is the direction of the induced current? Remember, your textbook always assumes conventional current. And it says that the wire is being moved towards the east. The wire is moving this way. Okay, so this is V. So I point my fingers in the direction of the magnetic field, my thumb in the direction that the wire is moving in. My iPad just flipped the picture around. There you go. And my palm is going to be facing into the page when I do that. And when we started, I said, if this is west, this is east, then north is into the page and south is out. So this current is going into the page, which would be north. Okay? That's number 1. Number 2. A wire 1 meter long is moved at right angles to the Earth's magnetic field where the magnetic induction, in other words, the magnetic field strength, is 5 to the negative 5 teslas at a speed of 4 meters per second. What is the EMF induced? So EMF is equal to BLV sine theta. So EMF is equal to, so at this spot, it's 5 times 10 to the negative 5 teslas. It says the wire is 1 meter long, and it says it's moving at a speed of, that's 4 meters per second. So it's going to be 20 times 10 to the negative 5, which is going to be 2 times 10 to the negative 4 volts. Number 3 says an EMF of 2 millivolts, so 2 times 10 to the negative 3, is induced in a wire that is 0.1 meters long when moving perpendicularly across a uniform magnetic field at a velocity of 4 meters per second. What is the magnetic field, magnetic induction? In other words, what's the magnetic field strength? So magnetic induction and magnetic field strength B, they're all the same thing. So we're solving for B, EMF divided by LV, because it said perpendicular, so the angle's 90. The EMF, it told us, was 2 times 10 to the negative 3 volts. The L, it told us, was 0.1 meters, and the speed was 4 meters per second. So you're going to get 0.005, I believe, teslas. Number 4. In number 4, with what speed must a 0.2 meter long wire cut across a magnetic field for which B is 2.5 teslas if it's to have an EMF of 10? So again, rearranging this time for speed. And it says perpendicular, so V is equal to EMF over BL, so V is equal to 10 volts, I believe it told us. The B was 2.5 teslas, and the L was 0.2 meters for 20. V is equal to 20. Oh, it's meters per second. Didn't I already do this question? Look, it's exactly the same numbers as the one you did on the other page. Wow, the book's not very creative. All right, that was it for your homework. Hopefully you got some of your assignment done too.